All right, teams. Team Iris, you can start thinking about coming up here, but not quite yet. So we're very fortunate today to have 4 esteemed judges with us. We're going to give them a couple of minutes just to say something about themselves. You guys have all worked with the pointer before, so you know that down means advance. Professor Fred will make sure that your PowerPoint is up and loaded, so you should be in good shape technologically. We will not have, famous last words, we should not have the issues we have with AV over in Rec Center that we have here. AV system is considerably newer and better here. Teams, what I want to tell you is you've worked hard. You've done a lot of work. You've had a lot of fun the last 3 days. It's been great getting to spend some time with you. Now's the moment of truth. You've done the work. In the NBA, we say you've done the work, you've made it to the basket, put the ball in the hole, right? Now's the time to do it. Somebody's got to win. It might as well be you, right? Be on your game. You're probably a little nervous. It's okay. They understand that. Give it everything you got. Before we get started, I'm going to allow the judges to give you a quick snippet on themselves. Dr. Abbas, we're going to start with you.
Sure. Howdy. Howdy. You guys know me. I spoke with you guys on Monday and every day this week. I'm Maria Alves. I'm the Senior Director for Halliburton Engineering Global Programs. I'm looking forward to see the presentations. I saw yesterday the prototype, so many great ideas. I think we're going to have a very hard job. So good luck, and we're looking forward to see your presentations today.
Howdy. Howdy. I'm Paul Deere. I'm a professor of practice here with the Malloy program. Went to school here, graduated with a degree in electrical engineering, went out and started a company, built that up in solar, so I have some experience with entrepreneurship and commercializing new technologies. I've seen a lot of your stuff yesterday at the poster session, and I'm looking forward to hearing your presentations.
All right, howdy.
Howdy.
My name is Richard McDonald. This is my 3rd time to be here as a judge for Invent for the Planet, so thank you, Fred and Jim and crew, for having me back. 1999 graduate of Texas A&M Electrical Engineering. Spent 18 years in a global technical role, doing business in over 30 countries around the world, and then about 10 years ago started my own business that I'm running now, as well as 3 other companies. So just glad to be here, happy to be a resource during the breaks or afterwards if you have any questions on global corporate roles or starting your own business. I'm happy to be of assistance. Welcome.
And the final, howdy.
Howdy.
My name's Chris Curran. I'm also a professor here at A&M, teaching entrepreneurship. I've been doing this for 4 years. And before that, I spent about 30 years in the consulting business, helping companies think about innovation, helping companies figure out how to do some of the thinking like you're doing here on a larger scale, which is really hard for big companies. So I spent a long time doing that. And then at the end of my career, spent some time starting some software businesses for a big company. So that's my background. Good luck, everybody.
Thank you. Team Iris, come on up, get settled in. Teams, this is how we're going to work. You're going to get settled in. There's a 10-minute clock that counts down. Right here, you can't help but see it. You'll have your 10 minutes. If your presentation goes longer than 10 minutes, we'll shut you down. So don't make your big point at 10 minutes and 10 seconds, because it's not going to happen. Table here for your prototype. You do not have to use microphones because you're right here with the judges. The reason we have microphones for the judges is so that when they ask questions, that everybody in the room can hear them because they're not facing you. They'll be able to hear your answers. Okay? So if you would, get settled in, look at me. I'm going to sit over here on the side. I will moderate the Q&A. You've got 10 minutes. They'll give the judges roughly 5 minutes for questions. Okay? But look at me whenever you're settled in. Take your time to get settled in. Just look at me when you're ready to go and don't start until I give you the signal. Okay? Fred, who's running the clock? You? Who's starting the clock? Professor. Whenever you're ready.
Howdy.
Howdy.
Good morning. We're Team Iris from Ireland, and we're here to present our solution. So I'm going to present a quick video about the problem we're solving.
Every 60 seconds, another home is needed in developing regions. And in that same minute, over 1 million plastic bottles are discarded worldwide. Across underdeveloped countries, families live in unsafe structures, while their streets and waterways overflow with plastic waste. Traditional building materials are expensive and often unavailable. Meanwhile, plastic pollution continues to devastate these communities and their environment. But what if this waste could become the foundation of a better future? 2 crises, 1 innovative solution. Introducing Replast, a revolutionary kit that transforms plastic waste into durable, interlocking building blocks, just like the toys that inspired generations of young builders, but engineered for real-world construction. Our innovation turns a community's plastic waste into its greatest resource. Here's how Replast works. The community collects plastic waste. Our portable sensor will detect the suitable melting plastics. Then we melt them and put them into a modular molding device to shape the bricks and construct a new future. We're cleaning environments and transforming communities to build a future where waste becomes walls and pollution becomes possibility. Together, we can construct hope, one recycled brick at a time.
Our need statement is to create sustainable housing solutions in underprivileged areas. We're especially focusing on the areas that deal with plastic waste.
Plastic pollution and poverty are the 2 of the most important challenges of our time. At the first glance, they might seem unrelated, but in many parts of the world, they are deeply interconnected. In densely populated low-income regions, poor waste management causes plastic to accumulate, worsening pollution and living conditions. Meanwhile, lack of resources and infrastructures leaves over 100 million people homeless. According to UN Habitat, an estimated of 96,000 affordable homes needs to be constructed every single day to meet the growing housing demand by 2030. I repeat, an estimated of 96,000 affordable homes needs to be constructed every single day to meet the growing housing demand by 2030 to have the roof over their head. This leads us to a critical question: how are we going to build a house which are both affordable and sustainable?
In order to tackle these problems, we came up with 3 ideas. Our first idea was repurposing cargo containers, and our second idea was fabricating bamboo. However, we didn't go with these ideas as they require high maintenance and are prone to decay. So, we decided to go with our third idea, the recyclable kit, which uses local materials and cultivates self-sufficiency, allowing the people to build a future for themselves.
So we are presenting to you here our solution, the Replast Kit. We envision our Replast Kit to help and enable the communities to identify, collect, and repurpose the plastic waste, transforming the waste into an opportunity. With an easy-to-use, cost-effective solution, we want to help the underserved communities build self-sufficiency, promote entrepreneurship, and be able to transform this waste into reusable goods and sustainable infrastructure. We want to empower an individual who can in turn empower the community.
Around the world, various organizations like Conceptus Plasticos, EcoBricks, and CoBrick have started a movement to turn plastic waste into building blocks for change. This is very inspiring, but we need to move one step further and generate something new. And this is where our Replast Kit come into picture, where creativity meets purpose. Our Replast Kit is all-in-one solution which will help the communities to empower themselves by turning the plastic waste into something which is very durable and high quality. And while other people are trying to create something change around the world, our Replast Kit is trying to make a bridge for future.
So here we are going to present to you our prototype, the kit, which comprises of 4 stages of operation: the segregation stage, the treatment stage, the molding stage, and the assembly stage.
Now, in the segregation stage, our aim is to segregate out plastic that emits low to no carbon during melting. Our inputs being plastic cans or plastic bottles that are of types polyethylene, polypropylene, polystyrene, and our output being an indicator such as our handheld device that indicates whether the plastic can be used in further processing. Now we'll take an example. Our handheld device that consists of a near-infrared sensor, a thermal sensor, and a microcontroller. And if we were to be scanning this plastic bag, the near-infrared sensor helps us detect the type of plastic based on the absorption and reflected rays. Now the green LED indicates that the plastic can be used in further processing, that is in shredding. And versus if we were to be scanning the plastic that is not suitable for the further process, The red LED indicates that plastic cannot be used in further processing and is sent out to industries that can be recycled in its traditional methods. It also contains a thermal sensor which is used to monitor temperature during the treatment stage.
So now that the plastic is well sorted, we can proceed with the treatment process. The first step is to shred the plastic in smaller pieces that are easier to handle. And then we will mix this plastic with sand to increase the properties of the material. And the possible ratio is to use a 40% of plastic, 50% of sand, and then an extra 10% of some other local available material, such as clay, coconut fiber, or fly ash. Then the next step is to melt it. And what we are going to do is to take this mix of plastic and put it inside of a pot. And then, using locally available heat sources such as campfire, gas stove, or electric stove, we will melt it. And during this process, it's very important to control the temperature of the mix. And that's why we have decided to integrate a thermometer inside of the Inendo device provided with their Plus kit. The last step is to mold the brick. So this is a 50% scaled down replica of the mold that is provided inside of the Plus kit. And what we are going to do is to pour inside of the mold the melted plastic. Then we are going to close it and apply some kind of pressure to consolidate the material inside of it. And then we will let it cool down. As soon as it's cold enough, we will open it and we will finally extract our brick. Of course, this is a scaled version, while this one is a full-scale replica of the brick made using the Plus kit by the local community using scrap plastic and local available resources.
Our modular brick design is engineered to be interlocking, allowing users to stack them just like Lego. This makes construction faster with no additional skills required. People can use our modular bricks and be creative with it, and use it to build walls, fences, furniture, and even houses.
It's not just a machine, it's a movement. It's portable, you can take it anywhere, make anything out of it. It grows with your vision. It empowers the community, and it's just need the willing hands of the community to build something for themselves. And this is how their local actions make a global impact and create a circular innovation for the future.
Here we have our estimated cost breakdown for the production of plastic bricks made of 50% sand, 40% polypropylene plastic, and 10% of other materials. On the left, you can see a comparison of melting costs using electric and gas stoves in different regions. For instance, in India, using a small electric stove to melt enough plastic to make one brick costs just under half a cent, while using a gas stove costs about 1.4 cents. The prices are a bit higher in Africa and Brazil, but still remain very affordable per brick. On the right is a pie chart showing the total setup cost of our kit, which is $220, with the biggest investments going into electronics at $95 and the mold press at $87. The other costs are relatively low. This shows that our solution is not just scalable and sustainable, but also energy efficient and cost effective.
To make sure that the project is commercially viable, we're going to apply strategic partnerships in place. We plan to collaborate with global NGOs for funding and support, government for grants, as well as corporate CSR initiatives that tackle sustainability. Additionally, local engagement, crowdfunding, and tech solutions will help us scale further.
For our future work, we want these bricks to support more than structures, but the community on a large scale with additional support. We see possible integrations of our modular brick design with pipes that can help us channel and direct water for storage and other applications. This reduces the need for additional infrastructure.
In summary, a Replus kit is not only a sustainable solution, but is a tool that would help communities to build a future for themselves. Thank you.
Nice job, Team Irish. Judges, the floor is yours. If you would use the microphone just so everyone can hear your question.
Thank you very much. That was very informative. As far as scale, building the bricks one at a time with the molds, with the amount of housing that's required that you mentioned, might take quite a while. Have you given any thought into how we can scale up the production of the bricks faster and removing the pollution at the same time?
So how is seeing the scaling part here? We've started with the community where they are starting to use the plastic and then recycle it. But the scaling part can come in picture where local entrepreneurs or local market players can come in picture and take over some steps. For example, the shredding, for example, the melting. These could be controlled more and these players could come in picture to make it faster. So it would be more for the people but also let them take up more opportunities for themselves as well.
As far as entrepreneurial opportunities, what do you think a sales price for a brick would be? How are you going to motivate an entrepreneur to want to do this? How could they make money doing this at scale? What would that mean? What would it cost?
Our idea is to work kind of like an NGO. So we're gonna give the kit to the community, and they can further apply it to themselves. So there's already places where they have some NGOs and some companies in place, and we would give the kit, and they could apply it for their own production to help the community. And some people might see it as some type of business idea, and they can use it for themselves. That's how we're gonna prepare the production.
Okay. Have y'all made a brick with recycled plastic yet? No. Okay. Plastics have different mechanical properties. How can you ensure that each brick has the properties you want for construction? One of the things I would be concerned about would be like air, like how you evacuate the air or de-air, the plastic when it's heating up and you're mixing. Because if you have a bunch of air in it, it may not be structurally sound.
So the air which will, you might say, like it's released while melting or making the brick process, we can try to filter it out using carbon filters and carbon shields. It will help it to not get released in the environment practice. And coming towards how to make it, the ratio, we are trying to put it in a ratio like sand and plastic together so that it becomes more durable.
And I have one more question. Have y'all thought about maybe an extrusion process where you can extrude like 2x4s that are more traditional building materials for roofs?
Sorry, we didn't get your question.
Well, what about if you had an extrusion process where you could extrude like a 2x4, what we use here in the US to build roofs and trusses with, as opposed to just only bricks? Have you thought about lumber?
I think in the future we would address these situations as well. Like we would give this kit to the community. We would get feedback from them, like if they require extrusion or like they require a different shape of the mold, we would provide it to them. Like the extrusion, we have thought about it as well as sheets as well.
Thank you.
What are your thoughts on the toxicity of the gases that come out of melting plastic?
I'll just repeat what she said in terms of the plastics that we are catering here, which are only the 3 types. We specifically went with that because first it is the most available plastic pollution around, and second it kind of emits low to no carbon, but also to control that in terms of the melting step, we wanted to propose carbon sheets which can help ventilate during the melting. So the pot in which we are going to pour the mixture and then heat it, we would have a lid for that, which could be made of carbon sheets, which are cost effective as well, and they could probably absorb the carbon emissions.
So some of the kit includes the melting kit or add-ons to pots that people could
Yes,
apply to try to filter some of the gases. Because just because it's not emitting carbon doesn't mean it's not emitting poisonous gas, right? Okay.
Judges, maybe one more question if anybody has one.
On your cost structure, how much is the cost per brick? Is that per brick, the $220?
The $220 is for the whole kit.
Okay.
Like including the mold cost and the electronic costs.
Okay. So after the initial cost, how much would cost per brick?
It would be cost like just under half a cent to make one brick in terms of energy usage.
Energy.
Yeah.
And the material that you need to buy.
Sorry?
The plastic comes from collecting, but then the sand and the other 10% of materials, sand would they need to buy or can they just get from whatever.
From the regions where they are living, the regions that we have targeted, we've noticed that they have a lot of sand around them, as well as the additional fibers such as coconut, ash. They have it in their region, so they can just use those materials to build the plastic.
Thank you.
Okay, thanks, team. Team Gaia, come on up. Gaia, did I pronounce it right?
Yes.
I got some coaching. So we're gonna give the judges just a minute to finish up their grading, but you guys come on up and get settled in. It's the same one you used the other day.
Oh, so
Down button is forward.
all right.
So you guys get settled in, but don't start until I give you the cue. Okay.
Okay, no problem.
Whenever you're ready.
Howdy.
Howdy.
We are Team Gaia from Brazil. My name is João.
My name is Gabriel.
My name is Paulo Gustavo.
And I am Rogério.
And we are going to present you a nature-based draining system to tackle flooding in cities called the modular rain garden.
Every year, floods become more frequent. Cities suffer the impact, damage losses, and affected lives. How can we keep living in this condition?
We need to act and react. Cities around the world are adapting.
Retention basins and rain gardens help mitigate the impacts of climate change. But these approaches still demand a lot of time and money.
Now, this solution can be implemented even more quickly and efficiently.
Introducing the modular rain garden.
Our modular system simplifies installation, reducing costs and saving time.
A nature-based solution that transforms how we manage rainwater, with coconut fiber and supporting a circular economy. Planting native plant species that enhance local ecosystems and help mitigate urban heat island. The images showcase the proof of concept in action, rainflow and returning the water to the soil. Our solution focuses on being acquired by governments, companies, and residential complexes looking for efficient and sustainable urban drainage solutions.
What are you waiting for?
Use Gaia today.
How is flooding affecting society's well-being? Global warming and climate change are causing a constant increase in floodings all around the world. For example, in Florida, the US, Bangladesh, India, Rio Grande do Sul in Brazil, and South Texas in the USA. Everyone is facing this challenge that are impacting negatively the population. Ecosystems are being jeopardized, families getting apart from each other. Dozens and thousands of fatalities are happening all over the years. And in 2024, floods caused 9,000 fatalities. 40 million people got displaced, and the world faced $500 billion economic losses. And what have we done so far to address this problem? How can we ensure the well-being of society? Rain gardens are a way to solve this problem and mitigate floodings all around the world. This solution has three main advantages. It is a nature-based solution ensuring green areas all over the cities and ensuring that key islands can be decreased. It is a solution that can drain the water from rainfalls and transport it over the top of the layers through the bottom, the deepest layers of the soil. And mostly important, it can decrease floods all over the cities. But this solution presents two main drawbacks, making it difficult to be implemented. It presents a high cost to build and install and require considerable time expenditure to build and maintain. Our solution, the modular rain garden, is here to address this issue and ensure that this solution is the perfect one to fit the problem and to ensure the well-being of society, being a low-cost product of fast installation and highly scalable, being easy to install and ensure the well-being of society. Our main client and customers are governments that can scale this product but everywhere in every city all across the globe.
So why choose the modular rain garden? We have here a standard approach of a regular rain garden, and as we can see, it takes a lot of steps to be done. We have to dig a hole, put a gravel layer, put a sand layer, a soil layer, then plant the native plants on the garden for it to be ready. And with the modular rain garden, we reduce all these steps to only 2 steps. So the regular rain garden should take days and weeks of constructing, depending on the project parameters. And with the modular rain garden and reducing it to only 2 steps, we can take just a few hours to get it ready, right? Because we only need to dig the hole and put the module inside it, and it's already functional. We have also some monitoring features as the humidity sensor and the flooding layout of the system. As we can see here, we have a sensor coupled to the modular rain garden, and as the rain starts to fall, this sensor sends a sign when it achieves a certain amount of humidity to our wireless sensor that receive this sign and send to the government monitoring centers. So the government has time to take the right measures to warn the population, because it will send this sign before the area starts flooding. And we have here 5 important topics of our product. First of all, it assumes different geometries. So basically, if our customers want a different shape garden, we have 2 different modules, 2 main modules. There is the cubic one that we have here, and the triangular prism one that we use to compound different shapes fitting to any client necessity. It is a globally applicable solution because we use the porous material that we dispose in the area. So, for example, in Brazil we have the coconut fiber, but we can use bamboo fiber and other materials to compose it, and nature and the local plants. We use also a smart system, as we told you before, with the sensors for helping monitoring the status of the gardens. It is a nature-based solution because it mimetizes the nature behavior. For example, if you have a forest and it starts a heavy rain in the forest, it can drain the water to the deepest layers of the soil, and it's exactly what our modules does. And we have especially team support to help our customers to keep their gardening always functional, always green, and always living.
These are the technical specifications. Flow rate, module size, and different kinds of materials, just coconut fiber and bamboo fiber and others. It presents 19% cost decrease and considerable installation time reduction.
In addition, our products can accomplish six sustainable and development goals. Here we have some achievements and milestones that we faced all around our journey with this project. First, we made a conceptual design to understand what kind of shapes would fit more perfectly to the projects that we would use the modular rain garden. After that, we built the first prototype to understand how the water would flow through the garden and through the deepest layers of soil. Then we built our new prototype with the shapes that we would use to sell to our clients and made a proof of concept. And from that prototype, we took the technical specifications. Then our next goal is to develop the wireless system to help the government monitoring the flooding. Right? After this wireless sensor is developed, we would encapsulate it together with the humidity sensor, making a tinier sensor that would be sold together and coupled to the modular rain garden. We'd like to thank you for the opportunity to be here presenting to you, and we'd like to ask you one more time, what are you waiting for?
Choose Gaia today! Nice job, Team Gaia. Judges, any questions? Team Gaia.
Obrigado. Bom dia.
Bom dia.
Who would be your target customer? Building these solutions with raw materials is oftentimes maybe less expensive on scale because the raw materials are cheaper. So obviously there's other aspects involved here, but I'm curious who would be your target customer for the price point, say price per square meter of rain garden that you're trying to install?
So our main target customer will be the government at our first point, because they can scale the product, they can put elsewhere, and they can put in universities such as Texas A&M. So it would be more easy to make this system to work and diminish floods. But also, as the company increases, we can sell to other customers such as small clients, people who want to put in yards. So we are pretty flexible, but the main one, governments.
What have you learned about the square meters required to impact flooding? How many modules would you have to have in a city to actually impact the problem?
All right, so it depends because this one we had the estimation of 1,600 square feet, and it would require something near 100 modules with a bigger size of 20 inches of walls that can lead to 90% cost decrease. And we have tinier versions, but we have a limit to fit. So,
and the 1,000 you said square feet?
Yeah.
Is to impact what type of problem?
We are aiming to decrease floods around the cities because these modules can absorb the water from rainfalls and can let them to the soil. So,
right, so what I'm asking is, for a city,
yeah.
How many of these rain gardens would you need?
Full rain gardens.
How many of these different installations would you need to impact flooding?
Depends on the project parameters.
Okay, so give me an example.
If you have a city that has a huge volume of water from time to time, right? We have the flow rate of one module, and we can make the calculation based on this flow rate. So it will depend of the parameters of the city. How often it rains, what is the rain volume, and we have this data to make the project work, right? So it depends of the project parameters. but we can calculate it. It's not something that we don't have any idea, right? We can make this happen.
Like in Rio, do you have an idea how many of these gardens they have right now in Rio or in a neighborhood in Rio?
In Rio, we have a few gardens of it. It demands a huge quantity of money, and it demands also will of the government and fix this kind of problem. And we have our 50th member, Tashenka, didn't come with us, and she works with it, and she told us that in Rio we have children gardens, just two, and the noblest zone of the city. So it's still lack of implementation in our city.
And does she know how many they need in Rio? So right now you have two in this neighborhood. How many they would need in this neighborhood to have an impact?
Well, in the south zone of Rio de Janeiro, they could have plenty more. We don't have the exact number because we didn't have the time to make this research and bring to you more comfortable data about this.
That would be great to know for the next steps.
Okay, maybe one more, Judge.
You know, here in the United States, you see, well, at least here in Texas, you see a lot of retention or detention ponds, right? Are you suggesting that you would replace the detention ponds with your solution? And if so, would that be better than a pond system?
Yes, we can substitute what we have for the modular rain gardens because they drain the water flow and they increase the green area in cities. So we also fix the heat problem in big cities, and they will give it a distance to the rain and also down the temperature a little bit.
Okay, thank you, team. Team Aquarentures. Mess. Still have that paper towel by chance? I know.
Silverware back there that I stole that. Everything but natural water.
You guys also, this goes for, yeah, so you just like to walk down this forward. I'm not giving you. When you're ready.
So, good afternoon, esteemed judges and colleagues. We are the Aquarentures team, and we would love to introduce ourselves, starting with Walid, Ahmed, Noor, Muhammad, Riham, and me, Ahmed Saleh. Now let's get to watching our video.
Civilization as we know it was built around water. It is the backbone of every society here on Earth. Today, over 2 billion people rely on rivers for drinking water. What happens when these waters turn toxic? We are currently harming our water resources, and more specifically, rivers, by throwing everything into them. By throwing trash, chemical waste, and contaminants to make life very difficult for everyone here on Earth. The deadliest threat is invisible. Heavy metals, lead, mercury, arsenic, seep into water, silently poisoning millions. Children are most vulnerable. Lead exposure alone causes brain damage and over 1 million deaths yearly. At HTU, we saw the urgency and we took action. We scoured the research papers, experimented, and refined prototypes to create an accessible, reliable detection system. A curcumin-based biosensor, reacting instantly to contamination through a simple color change. But we didn't stop there. We integrated microfluidic technology, ensuring faster, more precise, and multi-contaminant detection in a compact, portable device. Affordable, sustainable, scalable. Unlike expensive lab tests, our biosensor is simple to use, empowering communities, NGOs, and individuals to test water anywhere, anytime. This isn't just an innovation, it's a revolution in water safety. This is just the first step towards clean water and a safer future. Join us. Aquarentures, see the invisible, stop the inevitable.
So, rivers have always been the foundation of human civilization. From the fertile banks of the Nile to the winding paths of the Amazon. These waterways have shaped societies, sustaining life and driving progress. Even today, approximately 2 billion people rely directly on rivers for drinking water. Yet, these vital sources are increasingly under threat. And this isn't a distant future. This is happening now. And we are here to change that.
Fast forward 6,000 years, as we continue to industrialize and urbanize, our rivers are paying the price. Pollution is surging at an alarming rate. Oil spills, agricultural runoff, and untreated sewage are the most visible issues. But beneath the surface lies an even greater danger, one that cannot be seen, yet it's just as deadly. Toxic heavy metals are seeping into our water and silently poisoning those who depend on it. So, how do these dangerous metals end up into our water? In developing countries, one of the primary sources of contamination is the mining operations. The United Nations reports that industrial discharges are responsible for up to 70% of the industrial discharges are responsible for up to 70% of the contamination in the world's rivers. But this issue is not limited only to developing countries. In developed nations, another major source of contamination is the degradation of old lead pipes. For example, in the United States alone, the EPA estimates that over 9 million old lead pipes remain in place, leaching lead into water, which make water contaminated. In Texas alone, there are almost 3,000 reports of groundwater contamination due to oil drilling. So whether in rural villages or urban areas, water contamination from heavy metals is a global issue.
The thing is, it is really simple to get rid of heavy metals in water, as simple RO filters take care of it effectively. It's a problem of detection and water quality monitoring, especially because heavy metals are really harmful, especially for vulnerable populations like children, as exposure to lead can cause severe developmental delays, learning disabilities, and organ damage, while exposure to arsenic can increase the risk of cancer and cause respiratory diseases. Heavy metals are silent killers, harming children and communities for generations, often without them even knowing it.
Approximately 250,000,000 children worldwide are exposed to lead levels that pose a health risk, and almost 200 million people worldwide are exposed to arsenic-contaminated drinking water. Globally, up to 1.5 million deaths annually due to lead poisoning, and for children being particularly vulnerable. In one unbelievable example, the town of Kabwe in Zambia suffered from lead contamination. Over 95% of the children in this town were found to have dangerously high levels of lead in their blood. But this is not an isolated case. It's happening in communities everywhere.
How can we solve the problem? If we can't even see it. Fortunately, there's a solution. It is simple, affordable, and powerful. Introducing our groundbreaking curcumin-based biosensor, designed specifically to unravel hidden threats in our water, like lead and arsenic, so we can finally take control of what is poisoning us. Our idea is made up of two parts. Firstly, a microfluidic testing chip, which contains curcumin, the active compound in turmeric, and the calorimeter unit, which converts this color change into the actual concentration value of the liquid. Our idea is based on recent groundbreaking research that proposes we can test different heavy metals using curcumin. So, our analysis makes use of those materials to test for different heavy metals. We're going to be the first to implement this curcumin-based system into a practical, on-the-ground solution. Also, our sensor doesn't just detect these heavy metals effectively, it does so reliably and in real time, so we can provide immediate, actionable results that will save lives. We're also taking the solution a step further by integrating cutting-edge microfluidic technology, which will allow us to make our solution more precise and have a faster reaction. But what really sets our solution apart is that it is small, affordable, and accessible, making it competitive with the existing solutions in the market, which are either too expensive or too complex. So it's a novel approach that empowers communities to test their water quality using natural materials with ease and at a fraction of the existing solution.
Our solution is not just powerful, it's really cost effective. By using curcumin, a natural and abundant compound, we're reducing the cost of the materials needed for our product. Microfluidic technology, while it's cutting edge, it's also highly efficient in terms of fabrication. We can produce microfluidic chips from recyclable materials and at a low cost. Together, curcumin and microfluidic technology enable us to offer a product that's not only accurate and reliable, but also affordable to scale and manufacture for widespread use. So, for this prototype, the cost of the microfluidic chip is almost $1, and for the calorimeter is around $20.
The potential for this biosensor is huge. There are millions of people living in areas where water contamination is risk-regulated. Starting from rural village to urban areas, tested water is limited, but with this project we can change it. In developing communities, it can be distributed through NGOs and local governments. Even in urban areas like here, schools, health clinics, and even individual houses can easily buy it. For this project, we're targeting those 3 SDGs, which are good health and well-being, clean water and sanitation, and responsible consumption and production. This is where we need your help. With your support, we can take this project to the next level, rapid prototyping, real-world testing, and eventually a large-scale production. Let's take this technology to the communities that need it the most and start making a tangible impact on global water safety. Together, we can turn this vision into reality and create a safer, healthier world for the future generations. Thank you for your time, your attention, and your commitment to make this world a better place. Together, we can change the way we think about water safety and create solutions that works for everyone. Thank you.
See the invisible, stop the inevitable.
Judges, I guess they're passing out $20 bills. I don't know what
Which restriction for the
Any questions for Aquarentures?
So how the prototype works? How the prototype works?
Our prototype is security bit. It's a gift.
Okay.
Our prototype is actually inspired with the blood sugar testing kits. So we built our testing kit using our bio microchip. And what we have inside is microcontroller. We have color sensor, limit switch to know when the chip is inside or not. And we have OCD to give us the outside data, what we get in. So, for example, this is one of the chips that have 49 mixes. And we say we put the water and shake it, the color will start to make a difference. So what we are going to do, just start. So what we're going to do, put it inside, it's instantaneous, we read the color and tell us that it's safe or not.
So you need to get the water sample. You need to get the water sample in here as well as curcumin.
Yes, curcumin will be inside.
Inside already.
Yes, it will
so it would already be here.
Yes,
and then
a
we
few
just
drops
put
of
the
water. Yeah, that's how it goes.
Thank you.
These chips are not upscale. They're gonna be like much smaller. They are microfluidic chips.
Do you use one chip per test?
Yes. The idea is inspired from the blood sugar testing kit that diabetic people use. So we will be making the chips from recycled materials. Each chip would be almost like a lab on a chip. It's going to test different contaminants. The paper actually proposes testing for 17 different contaminants. So it would be recyclable and it makes use of sustainable material. So we could make them for one use.
And does it only report safe or unsafe, or does it give you a percentage of land, a percentage of?
Okay, so we can convert the RGB values of the color change into using our sensor into actual concentration values in micrograms per liter or ppms, and we can then compare those values to the safe threshold that is provided by the local government, and then the final result is only displayed as safe or not safe for user intuitiveness.
And could this be automated where you flush out the curcumin, put in a new curcumin, and so it's just on like a faucet, it's always there giving you a reading?
Okay, actually for the testing kit we have two options. One that will be we can use it to recycle. We can give you the curcumin mix and you fill it yourself. The other option is gonna be for commercializing, and you can have say one box that we have 20-50 chips that you can use it. So we have two options right now. That depends on our funders.
And they're not going to be they're going to be cost effective. So maybe you're going to get like a whole box for $3 US with 25 like chips inside the box.
Speaking of costs, I think your slide was talking about the cost of manufacture, or was that the price you would charge?
Yeah, so it's the cost of the prototype. It costed us like $21 US as total. But for mass production in the future, it's going to be much lower.
So what are you thinking in terms of the price you would charge your customer for the unit and for, let's say, 100 chips?
Yeah. So maybe like for the customers, it's gonna be like $25, right? But for us, the manufacturing costs, it's gonna cost us like less than $4.
Do you think you can make this device for $10?
For customers, like
No, I mean your prices. If you said $25, then $10 for the unit or less?
That's right.
Okay.
Judges, maybe one more.
Yeah, and something else I want to add. So this device is gonna be much smaller, right? It's gonna be like as big as like your phone, right? And the magnetic chips are gonna be also like very small.
Very nice prototype, and it's always great to see a prototype that works. So thank you for showing that. Did you investigate any other ways of using the Circumen without electronics being required? In other words, could you make it as a tab or a pill or some other way that can just be dropped into water to test it without any electronics or that sort of thing?
Yes, so actually, this chip works as a standalone. It's a basic chemical reaction that is immediately available. So you could see a binary yes or no result that is visible through naked eye. But if you want to know the exact concentration in micrograms per milliliter, you would have to use the calorimeter unit. So yes, you could use this as a standalone to know whether the heavy metal is present or not. But if you wanted more accurate results, which is usually much more complex and expensive in the traditional sense, so we provide it using the simple calorimeter unit.
Okay, we need to wrap up. Thank you, guys. Carbon catch, come on up. Get settled in. Whenever you're ready. Whoops. So yes, we're waiting on you. Okay, perfect.
Ladies and gentlemen, our world is at a tipping point. Consequences of carbon emissions are no longer just ecological. They carry on impact in every sector. We can't wait anymore. It starts now. Our goal is not only to capture CO2 from the ambient air, it's to convert it into value, into a product, into a business, into a usable and profitable resource.
When we started designing Carbon Catch, it wasn't just about engineering. It was about survival. Climate change isn't coming, it's here. We knew we had to act. This is personal, but it has to be. Unfortunately, we can't be there with you all today, but now our teammates will take you deeper into the impact and the future of Carbon Catch.
Compressing all the stress, asthma on my chest, running out of breath. They gon' know my name, when I'm on the joint, okay, going hard, hit them when it hurts, kill them softly, all stress, trying to clear my mind, even smoke less, hopelessness, but I'm in this running this shit, both legs, bro. Running around town, and they coming from my head, though. Funny thing about it, they don't know what's in my head, though. Skin some chilly.
As you just just saw, this is not just an ecological crisis. It's an economical sinkhole. Let's break it down. To make things clear, $800 billion, that's how much US economy lose every year just due to pollution in healthcare. On the other hand, 7%, that's how much a company can lose in market value just to be seen as not ecological. Sustainability is no longer a choice, it's a valuation driver. Can you believe that 78% of US customers are ready to boycott companies which are said to not be ecological? Not proven. Perceived. That's the power of image. And last but not least, in the entire world, 1 of 5 companies have been sued with legal actions by Ecological Coalition in 2023. Just an example in Texas, can you remember ExxonMobil, which have been making pay $14 million just by violating the Clean Air Act? The tide is rising fast, but the good part is we're going to turn this problem into an opportunity. Great ideas need great complexity. They need purpose. So we wanted our product to be easy to mount, profitable, autonomous from end to end, powered by almost nothing, frugal yet effective. Innovation without the maintenance, and that's exactly what we did.
We started with a coating system, paints, that captures CO2 from the air. Sounds clever, right? But once we look more into it, it has to be scraped off, repainted over and over again. Not reasonable, not efficient, not worth it. Then we look into industrial air captures. It works, but it's expensive, loud, the kind that needs plenty of megawatts of energy to run. We knew we had to find something better.
I'm pleased to introduce you Carbon Catch, a vertical autonomous panel which absorbs CO2 from the atmosphere to convert it into usable calcium carbonate. So here's the twist. We're not just cleaning the air and reducing your carbon footprints. We are making a product out of it. Just put it in front of a building, at the exit of a tunnel, or even in a park, anywhere Carbon Catch works.
Here's how it functions. A thin, anodized, recycled aluminum mesh rotates slowly at a constant speed. It is coated with hydroxide powder, and this powder reacts with the CO2 directly from the air to form calcium carbonate. Then, these carbonates detach into a water tank to be extracted and then purified. There's no magic, just chemistry. We make react some hydroxide carbon, calcium hydroxide with carbon dioxide to create calcium carbonate. Each square meter of our product can capture up to 2.8 kilograms of CO2 per week. To put that into perspective, that's the equivalent of more than 78 trees combined. And the result, calcium carbonate. The second most sought after raw material in industry after water, used in fertilizer, soap, papers, and even in semiconductors.
For building owners and partners, we reduce their carbon footprint and legal risks. We improve their brand image and ESG score. On another end, for the industrial buyers who are buying calcium carbonate from us, they're buying some eco-produced and bio-sourced calcium carbonate. That way, they reduce their supply chain emissions and improve their brand image. On another end, we are also selling some carbon credits.
But who wants our devices on their buildings? Schools, cities, industries? Not because they have to, but because they can turn the CO2 reduction into a real asset. In the US, reindustrialization is coming, but this time it's clean. Industries are under pressure to decarbonize fast. That's where Carbon Catch comes in. Tunnels and highway walls will become active air purifiers. Even schools and hospitals can turn clean air into a leadership. It's not just a question about reducing emissions. It's a question of making it visible, making it matter. Let's talk about business. Global market for calcium carbonate is much more than $47 billion, and it's still growing. Carbon Catch sits at the intersection of two types of buyers. First, the industrial buyers. They, for example, pulp and papers, agriculture, semiconductors, they will need our products to buy green carbonate. Then the second one are the calcium credit clients. We sell them negative carbon credits, and we allow them to have a complementary revenue that can attract even more the eco-conscious buyer. In the Texas, 100,000 companies are concerned about calcium carbonate.
Our business model is simple and circular. The device user is handling the device, calcium hydroxide and maintenance costs, and we handle the recovery and the selling of the calcium carbonate. We give back 20% of that sales revenue to the device user. And in another hand, we are selling carbon credits. To put that into perspective, a device is capable of capturing 4.7 tons of generating 4.7 tons of calcium carbonate a year. When we will be at full speed, we will be able to sell 83 devices per month that can absorb 4.7 tons of calcium carbonate. This will make us able to generate $4.4 million worth of revenue every year. We need $90,000 to get started. To do that, if we win the IFTP contest, we will use it and then add a mix of $80,000 worth of venture capitalists. We also thought about deep tech innovation funding from the BPI, which is a public bank of investment, and Texas Small Business Credit Initiative. A third way would be to use a $90,000 loan in a private bank that we will reimburse in around 5 months. We will be profitable in 17 months.
So we have the prototype. Now we industrialize, we scale, we lead. In the next few months, we will have the technical finalization using TAMU labs and also Ensemble Métier once. Then we will have the beta version and the funding, applying for investors. And after this, we will have the phase of business launching with our first clients in B2B. And we will finally have the scaling and globalization.
At the Robin Hood of Carbon, we take it from the air to give it back to the one who really needs it. Some companies are already interested by our product, but we need you to launch it. I hope you will be part of the adventure. Thank you very much.
Judges, the floor is yours.
Could you talk a little bit about your business model?
Yes.
So are you going to lease the units? Are you going to just place them and you own everything? Are you going to gather the materials, the carbon outputs, and then just talk about that a little bit?
Yes, so the device user is buying the device. We are placing it on its wall for free. We provide calcium hydroxide that they buy from us, and we are getting the calcium carbonate out of it, selling it, and giving back 20% of that revenue to the device user.
Okay, and how often would you have to service the unit?
It depends on the size of the device.
Okay, so you have financial forecasts, so what is your assumption?
For a classic device of 12 square meters, we are above every 2 weeks refunding on calcium hydroxide. And for the refunding of water, it's a complete closed cycle, and it's completely automatic every 2 weeks. Also, it depends on the sensor.
Forgive me for not being familiar with the chemical in the water, but is it 2 questions? One, is it safe to touch? And the second question is, what is the impact on wildlife with these screens? I know just sometimes birds fly into these windows and everything else, so I'm wondering what happens if the bird gets stuck in the mesh. So,
for the birds, the problem. The mesh can be, for example, in front of the wall of a building. So it's as a solar panel. It's just make part of the building. And for the chemical problem, just to make an equivalent, this is also used in the production of corn tortillas. So we know we have to put some security concern for it, because it's not like heavy sugar, for example, but it's totally not toxic in the ambient air if you're not just touching it. It's once it's installed, it's okay.
This right here is your proof of concept. And have y'all been able to capture carbon with it? I guess to get to check, I mean, how much carbon can you capture with something this size, you know, and then how much product can you sell? Do you have the data on this from this?
So we tested it in France, and we can make it rotate with a small motor. That's just cheaper. There's one engine that's right here, and we tested with the mesh with the powder. We just need to find a motor to make the hydroxide powder stay on the mesh. And unfortunately, we couldn't travel with the powder because it's not safe here. So we brought everything we could, and yes, it works. It can rotate, and yeah, it's just a motor moves.
But do you have any data on how much carbon you captured, how much product you created with this device?
So we capture 2.8 kilogram per square meters per week of carbon, and per year it's 41.6 tons of carbonate created. And as there is like about 42 megatons of CO2 emitted by industry each year, I think we're gonna need to protect.
How does you talk about two other competitive carbon capture technologies? How does this compare to those other two carbon capture technologies?
So excuse me, can you just precise the question, please?
In your
okay, yeah.
in your presentation,
I got it. Okay. So basically, as we said, we are first special due to our business model because we introduce a clean carbonate into the industry, which is not the case of classic carbon absorption. Secondly, it's not an entirely separated device to absorb carbonates. It can mix with the building of the city. It can be aesthetic. It's silent. So it fusions with the whole ecosystem in the town. So it's not a separated device. It can fit in all the ecosystem. I don't know if I answered your question.
The efficiency.
Oh, the efficiency. Okay.
The thing is, we can place multiple devices everywhere and use some unused ports. That's how we are thinking of the model. The idea is not to put a big container outside of the chimney from the land, just capturing that what is getting out of that chimney, but it's to capture CO2 that is in the ambient air and getting it a bit safer. We can place it anywhere, and also this device is very low energy consuming, so we can place it nearly anywhere.
Okay, we need to wrap up. Thank you, Team Agri-AI. Don't take the clicker. It's not a way to get a competitive edge. Not an appropriate way to get a competitive edge. So, let's move down and forward. Down and forward. Now the mic is on.
Hello.
Hello.
Hi, this is our team Hydra Shield, and we would like you to watch our video before we begin.
What if your home wasn't a home at all? What if it collapsed every time it rained? For millions of displaced families, this is not imagination. It's reality. Homes made of cloth, swept away by rising waters, belongings soaked, cooked, washed in slums like Qatar. Rain falls heavy, but clean water is scarce. Children walk miles to other neighborhoods just to carry heavy containers of water. 117.3 million people are displaced worldwide. 50.2 million are refugees. 68.3 million are displaced within their own country. Behind every number is a story, a family, a future at risk. If this was your child, if this was your life, wouldn't you want the word it's here?
As the video had said, if this was your situation, wouldn't you want someone to care? Now I know that that's a little hard to imagine because probably everyone here has a place that they call home. So just for a minute, imagine your home. And imagine that your home had lacked such sustainability that you had to replace it every year, despite living in the same location for 5, 10, and even 20 years. Now imagine that the same home provides no water, no flooring, and no protection from the elements. This does not sound much like a home. It sounds a lot more like a tent. But what we've just described is the reality that millions face every day. And this is the reality that we are trying to combat. We decided to start by listing our considerations and our critical points that we want to match. First, we want our product to be able to withstand the weather conditions and the elements that these people face, like wind, rain, and storms that tend to knock their tents down. We would like our products, materials to be locally sourced. That would help with shipping costs. And in turn, help to make sure that our product is cheaper than the tents that they already use, because what good is a solution if it's more expensive than the current solution? And on top of this, our product needs to be able to be produced in a timely manner, because these people are in dire situations and they need homes fast. We would like our product to provide water accessibility in the way that a home should. And we would like it to last as long as these people need it. Like I had said, tents on average only tend to last about a year, and people are usually in these situations for much longer than that.
Alright, with these design considerations in mind, we came up with 3 different preliminary designs. Our first idea was to replace the aluminum rods that currently exist in tents with something more durable like recycled plastic. That way it can break easily without sacrificing the tent as a whole. In other words, it can be broken and replaced easily. The problem is, this wasn't the long-lasting solution we were looking for, and it didn't address the concerns we had about water. Our second idea was more along the lines of modular wall design. So our second idea was composite resin wall. We wanted to make a composite using resin and whatever locally sourced materials the refugees can find, maybe trash, sand, dirt, anything like that. The problem with this is resin is expensive and it takes 2 weeks to fully dry resin, so it wasn't up to the production standards that we wanted. Design was the idea that we decided to move on for Hydra Shield. It met all of our requirements. Alright, so how does it work? Hydra Shield, it's a snap fit wall that works using a notch and a slot, so it can just snap together. This is an easy system that doesn't require any specialized labor or expenditure to set up. Refugees themselves can snap or unsnap as they desire. In addition, it comes with built-in floors. As you can see, there are 4 triangles. They make a square. That is the floor. So each wall comes with its own floor piece, and when combined together, it creates a floor design. In addition, one of the key features is a water collection system. So as you can see, there's an inlet at each wall. The walls have a gutter that can collect water, and as the water flows down the inlet, it stores in a reservoir. So it has a water storing capability. In addition, some of the walls can be constructed with windows or doors in mind to add to the feeling of holiness.
To give you a the internal workings of our prototype, so we have a cross-section view on the screen here. Usually, we have a notch that fits perfectly in our slot, and you can have it in 3 different orientations. You can have it from the right, from the left, or aligned. So you can add a couple of walls together to form different shapes of the house depending on family size. Typically, rainwater carries is accompanied by strong winds, so you get a lot of dust, debris, and leaves with it. So we have our mechanical filter on the top that kind of stops the leaves from getting into our system and clogging it. Once you have that, the water flows down the inlet line and to the sediment drain.
grids. Alright, where the sediments settle in, and once the water level starts rising, we have a little bit clearer water on the second tank. The sediment drain can be drained into your local farming setup or a community garden. And then we have our tap slot that can provide water to for the residents for different utilities. So our overflow slot here prevents buckling of the wall in case we have a lot of rain. So if we get a ton of rain, we have our beautiful overflow slot here that can just drain the excess water into our community garden. So water drain. There you go. So that prevents it from overflooding our walls and helps protect the system. Our product assembly, there are 4 walls, each can carry 113 liters of water. So we are storing about 452 liters of water per wall. We have added an industrial safety factor of 2. So in case we go over the limit or something goes wrong, we are still protected and secured.
Now I want to move to the comparison between the current solution, which is tent provided by UN, and the current solution from us, Hydra Shield. So first, Hydra Shield has long lifespan, which is average of 3 to 5 years, while tent only has 1 year of lifespan on average. And our solid wall on the floor is serving as a protection against strong wind and rain, while tents just collapse. And we save rainwaters on the water tank. And we have a solid flat floor that keep your belongings dry when there are floodings and where you can sleep on a flat floor. And Hydra Shield is made out of one material so that reduces producing time, and it is made out of easy to recycle material. We are using recycled plastic, so it's sustainable, and in the future if we needed to, we can recycle it again to produce a new Hydra Shield. And since we are keeping the waters from rain, we think we can prevent flooding. So to provide our impact, we are planning to replace tents with Hydra Shield, and that way we can decrease flood impacts. And we can provide long-lasting shelter against weather conditions like strong wind and rain. Our average lifespan is 3 to 5 years, and considering the fact that most of displaced people live in a tent on average of 3 to 10 years, I think that's a valid period. And since we are using recycled plastic and we are making it in a mold, we make housing cheaper and faster to produce and distribute. And lastly, but most importantly, by saving 50% of average rainfall water on heavy rain season, we improve access to clean water that can be utilized on daily life.
And that's our presentation. Thank you for listening.
You did a nice job of dealing with the elements that you were dealt. Sorry about that. Judges, the floor is yours.
The elements.
The elements, yeah. See what I did there?
Very interesting. One question I have is, tents are easy to ship from place to place where they're needed. What about the transportation of this? If you design it so there's an easy, seamless transportation or shipping method for your home?
The idea is that we would be able to get all of these materials locally sourced. I say all of these materials. It's made of recycled plastic, specifically recycled HDPE, and there are recycled plastic facilities all over Africa, the Middle East, India, and all over the world, really. So we would be able to get it locally, and we wouldn't have to ship it.
Have you compared the cost of a tent and the cost of your product? And what is the comparison?
So the current tent that you provide for a family of 5 to 6 people costs $420, and our product is 10% cheaper than that. I mean, it can vary depending on the recycled plastic cost on that country, but it's more than 10% less or 10% less. That's the collection price.
From the market.
Yes.
Where are the biggest tent cities today? Are they refugee camps? Or are they where are these tent cities today?
There are many different types of living conditions where a community will adopt tent living. Many cases are refugee camps, displaced populations. There are also permanent populations that live in tents, primarily in African countries.
Right.
In the country of Lesotho.
So who pays the $420 per tent today?
It's provided by UN from the funding.
So NGOs and United Nations and other aid. Okay. So they would be your customer. Okay. Got it.
Have you given any thought to how you might store excess water during the heavy rain seasons to kind of level out the arid summer months to still have the water storage versus just having it overflow?
Yeah, that was a great consideration that we did debate over time. We wanted to keep it to prevent the impact of flooding, so that's why we limited our scope to that. But yeah, there are potentially endless limits that, if possible, you can incorporate a community garden that has a communal water tank and hook all of these up to that water tank potentially, because these communities are so overcrowded that it's so easy to build all these setups. You just need one water tank and you will fill it up really quickly in a rainfall season. And as you mentioned, there's no rainfall for, I don't know, a few months in Africa at times. We were targeting Kenya, Nairobi, so yeah, we did study that.
There's maybe one more if anybody has one. No, hearing none. Thank you, Team HydroShield. Okay, you're right back. Team Deep Blue, come get set up. Good to have a backup plan. Students, while we have just a brief break here, after the last presentation, you're going to stay right here. There's going to be a QR code and a survey that you're going to complete. Once that is done, Danny, are you leading them up? This precious young lady right here, dark hair, the camera around her neck. She's going to lead you out to the stairs up by the Starbucks, and we're going to start taking some pictures. Judges and I are going to disappear down here and talk about you. Yes, we're going to talk about you. And then after that, we're headed to the chicken. You can't go to Texas A&M and not go to the chicken. In fact, Paul might lead a domino game later this afternoon. I mean, we're going there. Just so you know, we're going there next week ourselves. So it's a fun place. It's a short walk, and have lunch over there, and that's where we'll wrap up. Okay, Team Deep Blue, whenever you're ready.
Howdy.
Howdy.
Howdy. My name is Bakri, and with me I have Ilyas, Rayyan, Majd, Hayyan, and Ayman. And we are Team Deep Blue. And we are here to present you with an innovative solution to a really pressing problem. Let's start with a short video.
let's
I
take.
got it. Yeah.
You guys-
As the admittedly muted video explained, energy poverty is a real crisis. Over 750 million people worldwide lack access to reliable electricity. And most of these people are concentrated in just 15 countries. These countries are poor, rural and coastal communities such as Liberia and Papua New Guinea, in which productivity ends when the sun sets. These people don't get the opportunity to pursue their dreams, their passions, their work, their studies, leave them trapped in an endless cycle of poverty. Without life, without light, there is no life. And we want to give these people a fair shake at life. Our mission at Deep Blue is simple: to provide these vulnerable communities with a sustainable and reliable energy source. To achieve that, we came up with 5 solution requirements. First of all, our solution must be affordable for these poor communities. It must also be robust to withstand the tough environmental conditions in these coastal climates, be space efficient, easy to maintain for a long-term life cycle, and also, arguably most importantly, provide a clean and consistent output of power.
So the first thing we considered is solar panels. Since we want to provide energy during nighttime and solar is only available during the day, we had to look into energy storage solutions. This initially gave us surprisingly great power output. However, the issue is the energy systems are pretty expensive, and solar panels degrade very quickly in the harsh climate regions, climate coastal regions. So, and also, and then we looked into windmills. Windmills seemed promising because they work very well in the coastal climate, and also they produce consistent output. However, their issue is they require a lot of space, they are pretty expensive, and also they are hard to meet. So we kept looking. Then we looked into wave energy converters, which makes perfect sense after all. If there's one thing coastal communities have plenty of, it's water, right? So, then they're also, they don't require land, and they're generally reliable. However, a key issue with them is that they require to be placed or deployed deep water, which makes them really incredibly hard to maintain and also impossible to afford. Nevertheless, the solution seems promising, so we kept looking into ways, researched ways into making them more practical and potentially truly usable.
On that note, it is my honor to present to you our solution, OmniWave, a reliable resource of energy which can be situated in close to the shores so that we can produce energy. We want to deploy our system at a stationary point such that along over here. After we install our system over here, we want to make use of the waves to operate our mechanism. How does our mechanism operate? The linear strokes of the actuator, as you can see in the video, apply force on the ratchet, rotating it in a direction, clockwise. And then when the linear slider moves downwards, the reverse actuator applies force so that the ratchet can rotate in the same direction. Our design is innovative and novel, and it introduces a futuristic design to the energy market. We had to cater to a few challenges. The wave parameters near the shore are not consistent, so our design is able to produce energy even when the amplitudes are very small, and it can continuously rotate the ratchet. We also made our design such that we can cater to the varying sea levels throughout the different times of the day. We made sure that our design can produce maximum torque and in turn maximum power because of the extra teeth that we've added on our design. We then made a software so that we can calculate the power generated in terms of the wave parameters and the device parameters. In Liberia, we calculated it to be about 280 watts, enough to power a few bulbs and a ceiling fan in Leila's house.
Now that we have a consistent rotational motion, let's convert that into electricity. We do that using a synchronous generator that gives us an AC output that is first converted, then inverted to stabilize it. That output is then measured by a voltage sensor that provides telemetry to a microcontroller that helps us assess the device's health and provide predictive maintenance. Let's now look at the power distribution. We first have our device, OmniWave, that feeds electricity into a substation that divides it based on needs. And finally, we have our end user, who enjoys all the benefits of OmniWave.
To calculate the cost of OmniWaves, we first identified all the important components that we have, and we found reliable suppliers for each and every one of them. After calculating the cost of all those components, we found that the total cost of the components is about $400. But we want also to include manufacturing costs. So this manufacturing cost can be provided by a company that has extra deep width that they can rent to us, and including the manufacturing, the total cost to produce one OmniWave device will be about $750. This might sound a little bit too much, but it's not very affordable for people like living in low-income coastal countries. But that's why we addressed this challenge by identifying a very strong business model.
We here at Deep Blue operate on a non-profit business model. What this means is that all of our revenues beyond our costs go back into R&D of the OmniWave device itself. Here we have three main stakeholders: our investors, our primary operational partners, and our end beneficiaries. On investments, we will initially use crowdfunding to get our company started. Then we will approach various incubators and investors such as Qatar Foundation, where we study, Qatar Investment Authority, which has pledged over $1 billion in investments, AgriAI, QDB, perhaps even Malloy, all of which host competitions for funding, which we have all participated in and won. We also approach multinational energy companies such as Shell, Total, British Petroleum, who are always looking to invest in something that is sustainable and has strong social impact. On topic of operational partners, for us, we have obviously have to interface with local governments, with their state-owned utility companies, such as PNG Power Limited in Papua New Guinea. But our primary partner will be some sort of multinational NGO. You're looking at, for our case, UNDP or Qatar Charity, which is an NGO with strong backgrounds in infrastructural development in impoverished communities, such as the ones we work with. It is in doing business with them and with their investors, we should be able to provide our services and our product at a highly subsidized, if not free rate, to our end beneficiaries, who are and always will be impoverished communities in countries such as Liberia.
Now let's take a look at our future roadmap. First, we'll start by raising some funds through the IFTV prize money, some crowdfunding, and some local grants. The next step is to reach out to manufacturers and vendors to build the first full-scale operational OmniWave. Now that we have an OmniWave device, the next step is to build the necessary operational partnerships with companies, Qatar Charity, for example, to deploy our solution in countries like Liberia. Having deployed and proven the feasibility of OmniWave, we can now reach out to key investors such as Shell, ExxonMobil, or BP to grant us the necessary resources to expand to a larger scale, develop OmniWave, add new features, and invest in our own manufacturing capabilities.
OmniWave aligns with 8 of the UN Sustainability Goals, reducing inequality and promoting sustainable communities and cities. For such a small cost, an OmniWave device will provide you with 280 watts of constant and reliable power for a 25-year life cycle. This electricity would run you $30,000 and 20 metric tons of CO2 in communities like those. In conclusion, we are offering an all-in-one solution to provide clean and reliable energy to the most vulnerable communities. Join us to make OmniWave a reality and give Leila, that was in the video, the chance she never had. Thank you.
Blue judges.
Marine environments can be very challenging, as you pointed out in your research. 25 years attached to the side of the dock. Seems like a long time. So I think there's going to be some amount of maintenance required on the mechanical parts, as well as during storm surges or other scenarios where there's the potential for catastrophic damage to the actual device itself. So can you speak to the claim of the 25-year maintenance-free relative specifically to the marine environment?
Yeah, so maintenance is a strong part of everything we do at OmniWave. You're looking at just a lot of asset lifecycle management. So you have 2 types of maintenance, as you mentioned. Preventative maintenance is just you're looking at the things, you might have visual inspection. It's like a checklist. A visual inspection every 6 months. You might have to lube it every couple of months. You might have to go ahead, take out the salt, decrease it. That's a part of preventative maintenance. Predictive maintenance is, as Ryan mentioned, grabbing the voltage and current and Hall effect sensor telemetry, and then running a machinery model back home in Qatar on how the model is performing compared to the wave amplitudes. Based on that, you can plot performance over time and figure out when it's going to fail. The idea for us right now is that when and if the material starts failing, we will look to replace the parts. The 25-year life cycle claim comes from the motor itself, the generator itself, synchro generator. At which point, if the generator fails, at that point, just get a new one. So that's what we use to link it. But we'll be looking to replace parts pretty routinely, especially the ones that are in a lot of friction, such as the actuators and the sprocket. Storm surges also you mentioned, which is slightly bit different. The idea of the model is to be able to withstand storm surges. Again, the telemetry should allow us to detect, we do this in Western countries quite a bit, to detect waves from like tsunamis and stuff coming in, not tsunamis, but like strong storms. You can detect it, run a model, figure it out coming, warn the country, warn the community that actually has ownership of the module. You just pick it up, take it back home.
What are your thoughts on scalability of this? The example is one unit in one house with a couple lights and a ceiling fan. So in a community where you have 50 houses, I'm talking about 50 units, and how they all fit on that dock, and where else would they go, and how would you scale this device?
Yeah, so of course scalability is an important factor to take into account. Now, the one unit or one home claim depends on the power draw list. Now, it's difficult to get power draw claims for these communities because the grid doesn't get to them, so it's hard to make estimations. But a typical LED bulb is between 5 to 10 watts. So if you have 1 or 2 or 5 bulbs in a house, this can actually power more than a single home. Now, if you have more complex loads, we're talking about a fridge or even some heating, then it would be 1 per house, 1 per unit. But an array of these, or larger ones, because part of the model is we can increase the diameter of the sprocket to get more torque and produce more power. So that's part of the versatility. You can make it a bigger one for a large power application, or have an array of them connected to one substation for entire community. And again, this goes with our business model. The point of scalability and subsidizing to the communities and offering them at a next to nothing or free rate.
Maybe one more, Judge. Okay, hearing none. Thank you so much. AgriAI.
There's a 3D model of this on the presentation. Unfortunately, it did not render it.
Partnership.
Okay, whenever you're ready.
Good afternoon, everyone. Before starting, we'd like to express our sincere gratitude to the Texas A&M community for hosting us and this beautiful competition. Today, we're going to present AgriAI, the ideas marketing culture for plant business.
Be pushing that.
Climate change have been hard to miss across North America and Europe. Record heat, wildfires, and warming oceans.
So it's no secret that our seasons look different than they did a few decades ago.
Now climate experts are warning these events have a devastating effect on the global food supply.
We wanted to know, what can the average person do to help reduce global warming?
Climate change is triggering global food production,
Rising temperatures, extreme weather events,
and water shortages are making farming more challenging than ever.
traditional farming methods are struggling to keep up. But what if we could harness the power of AI to revolutionize agriculture?
Introducing AgriAI, sustainable, efficient, impactful.
AgriAI is an AI-driven system designed to optimize crop yield and sustainability in a changing climate.
AgriAI integrates IoT sensors, satellite data, and machine learning to provide real-time insights and precision farming solutions.
Unlike basic monitoring systems, AgriAI takes action, learning, adapting, and optimizing farming like never before. Join us in building a smarter, more sustainable future for agriculture.
AgriAI, smart agriculture, where AI is farming for a better tomorrow. Today's presentation will go through the main aspects of our project. We are a team from Embry-Riddle Aquarentures University, Arizona. My name is Emanuele.
I'm Francesco.
I'm Diego. So what's the main problem here? Everybody has needs. You, me, everybody here needs food and water, which are some of the main resources, right? But where does all that come from? 70% in the world of freshwater sources are used in agriculture, and agriculture deploys every single food product that we have. So all these problems, like decreasing the supply of food chain, comes from the bad use of our resources that we're not using, like the fresh water. So how can we help that?
This heat map clearly identifies the problem you are trying to solve. As you can see, this is a recent map that displays just the United States of America. However, our problem can be expanded to all around the globe. States like Arizona, where we are coming from, Texas, where we are right now, and New Mexico really suffer about the drought problem.
Our proposed solution is based on AI-powered agriculture system that integrates IoT sensors, satellite data, and machine learning. We monitor soil health. We predict extreme weather events, and at the same time, we also have an automatic irrigation and fertilization system with drones.
Our project has both immediate benefits as well as long-term benefits. Immediate benefits include reduced water usage as well as increased crop production. At the same time, we aim to minimize the fertilizer waste. Long-term benefits include enhanced climate resilience, reduce the greenhouse gas emission, as well as improve global food security. While we are specifically targeting our solution to just one need statement, our project touches almost all 60 need statements provided in that of this plan. Our solution is composed by three main blocks. We collect data using IoT sensors. Data we collected goes through an AI-powered analysis. We built a machine learning algorithm that predicts when and where water and fertilization is needed. The outcome of the machine learning algorithm goes through and help for the automatic action that is built by smart irrigation driven by drones.
So we decided to design our prototype using SolidWorks and CATIA. With SolidWorks, we designed this power station with two solar panels, so photovoltaic panels on top, that through the cells that they have, they absorb the photon from the sunlight, and they transform into electrons, and so electricity. And we're gonna store this electricity inside a battery that we have inside the power station that allow us to charge our drone.
And a drone has a very initial simple design on the top that houses all the electronics, all the batteries and motors. However, the main part is in the bottom that houses the tank, where it could be any liquid pesticides, it could be water, and it could be anything that the farmer needs, and then deployed through these valves that then rotate and spin wherever the drone needs to go. This is a 14th of the actual size of the drone, and that's kind of like a 20th scale down of the actual shed for the drone.
These are the drawings that we made using SolidWorks to represent better our design. As you can see, we have the front view, top view, and isometric view.
At the core of our solution, there are the IoT sensors. However, unlike the IoT sensor already being used in agriculture, our IoT sensor will be built using just recycled materials. This will help for a greener planet, not just for the solution we are building, but also in the way we are building our solution. In this slide, we have a Python simulation we conducted to assess and test and validating, of course, our control station. As you can see, the drone operation is guided through water needs and fertilizer systems.
So what is the point of all this if we can't really expand and target everybody around us? That's the beautiful thing about this thing. You can go to small-scale farms, large-scale farms, pretty much anybody that needs it, because you can have one drone or many drones. Giving us a large-scale ability to provide things to everybody. And because of the use of the AI and the different software and all the materials that we're using for the drone and the shed, we have a higher competitive advantage than any traditional farming methods that are used, giving us a more effective and cost-effective solution.
We also conducted an extensive economic analysis comparing the traditional system currently used in agriculture with our very own solution, AgriAI. Despite an initial greater investment, the annual cost of our solution is way less. And in the left on this slide, we conduct a 10 years investment plan. As you can see, already after 3 years, we have an equivalent cost between AgriAI and traditional farming methods. The left graph shows the cost just related to maintenance as well as initial investment. After 10 years, our solution has 8 to 10% of savings of money. On the right part, of this slide, you can see the environmental impact. As said before, we have a better crop productivity, but at the same time, the volume of water use is less. And this brings two important aspects to the table. One, of course, this is better for the planet. And the second one is by predicting and anticipating predicting the water need, crop won't be waste due to be dry. At the same time, the water harvest ratio is way less. We also would like to share with you a brief overview of our future plan. After this competition at Texas A&M, we hope to build our working prototype and finding potential stakeholders, collect their feedbacks to validate our solution. In early 2026, we hope to finalize our brand and marketing strategy. And by May 2027, when everyone in this group will be graduating, we hope to launch our startup.
So why this solution? That's the main question. Why use this solution instead of any other traditional farming methods? Well, as we can see, two main things, the climate and resources. We're reducing the water usage by 50%. And that's the water, that's the 70% of water, fresh water around the world that's used just for farming. We're using less gas emissions because of the materials and everything that we're using, and helping our resources and the environment around us and the weather. This impacts the main thing because the communities around us, that's the main thing we're trying to help. And improving the climate and resources for the communities like water, food, the food supply and production, you're helping everybody. This combined with the core things of engineering like robotics, like energy and software development, provides a more sustainable, efficient and impactful solution than any traditional farming methods that are used today.
AgriAI, smart farming, sustainable future.
Any questions?
So this is a pretty comprehensive idea. How would you get started? What would be the first service or product you would offer?
We already conducted a simulation using 125 acres of field. We divided the acres of field in 10 different zones, and we implemented this system using the Python simulation we made before. How do we start? We probably start by the designing, that we already did in part, and build the working prototype, as I said before. Then we try to find potential stakeholders through a university and industry collaboration to try our solution.
So what I meant by how would you get started? Would you start with irrigation? Would you start with fertilizer? Would you start with some IoT sensor-driven analytics? What would you do? Because you couldn't do it all at once. So where would you start selling a product or service?
So the main thing that we would definitely start with, again, is the development of the actual drone and working prototype to test for different situations and environments, for winds and things like that. We would definitely test for irrigation. We would test for different type of soils and things like that. We would also test for pesticides and fertilizers and see kind of like the density of the water and if it can go through the valves. Kind of just testing the main design and then move towards the actual charging station and then eventually towards the sensors and implementing the actual software and the development we want to use. And then we just advance from there.
However, at the same time, there are already used sprinklers in all the agriculture industry. So our solution, our software solution can already be implemented also using sprinkler, and of course in the future they need to transfer to our drones and our system. Did you answer your question?
Great. Would the drones be your primary source of water delivery?
Yes.
So the 100 acres test area that you were looking at, how many drones would you need? And how much water can each drone carry to satisfy those requirements?
For 125 acres, we use 3 drones, and each drone can carry a maximum 20 liters of water. And each drone flight is lasts 20 minutes. For each zone, the 10 zone, irrigation time is 10 minutes.
I assume it would also vary by crop, depending on what they're growing.
Depending on what the needs of the plants and everything, and which is just pretty much determined by the IoT sensors.
Maria?
You said your initial investment is higher. How many years for it to catch up with the current one, or for them to start making money as a agriculture?
So our initial investment is a little bit higher, and just based on the cost of initial investment plus maintenance cost, after 3 years the investment is time. Plus, we need to consider that our solution produces 25 to 30% more crop. So, to sell the crop to the industry, already in 1 year we can tie the initial investment. But again, just initial investment plus materials and maintenance costs after 3 years.
Maybe one more judges. Anybody has one?
I would, having grown up on a farm, I would strongly encourage you to spend a lot of time talking with farmers and actually doing their job. It'll really help you understand a lot of the challenges and needs.
Actually, my grandfather is a farmer, so.
Perfect.
Yeah, yesterday we actually, with some of the people that came by the posters, this family from Puerto Rico, one of the persons I talked to was a farmer, and we were just discussing different ideas. He does drip farming, and which is pretty much a lot of the things we're trying to do here. And so he gave a lot of inputs and ideas, so that definitely can help. Thank you.
Nice job, guys. Okay, students, you can have a QR codes. Please fill that out. Please fill out the survey, and then pay attention to Danny in the back. Judges, if we could just run down here just really quickly. I know that two of you need to run, but we go to the boys' room. Okay, meet you down here.
Yeah, of course.
Yeah.
Implementation as judges. Implementation and scale files. When you mix it other presentations, we just show the action we use before here. It doesn't know that the audio broke and the same file is.
They knew you had audio. You're welcome.
Thank you, Mr. Jeff. We checked good enough to finish it.
I just have the ready.
Yes.
We can. Give extra lunch. I've given it twice. One time, I give a t-shirt myself. I'm not so young anymore. Still growing. Practice. Keeping at the right side. No, I was nervous at the station. Before I walk in, right, look at her, take her motivation, and then I move back.
I'm Marcella. I'm her. Nice.
It's okay. I was not sure.
When you talk about yourself,
Walk the house. I see her living at Gloria. I love that house.
this was for a page raise We were cheating. Mini golf. I didn't even go. I was at home. You quit halfway through.
That's what I have to deal with, you know?
She's like, no, that's hard.
I'll like it. Yeah. Sit down.
It's actually
Good 20, good 20. Highest for the better, right?
Guys, are there any materials you like?
It's live? Mariam is looking.
Friends over
Ice cream, what's the right? Even like halfway, so then I can take it on
Stand there. Stand there.
Yes, we would love to.
All right, team, let's settle in, please. Or no. All right, Danny, you ready to take photos? All right, let's follow Danny out this door, generally out that way. Huh? You lose it. We lose it whenever you do it. Who's gonna take the photos first, and then we're gonna come right back in here. Yeah. We're not gonna string you out. String you out. Photos first. Come on, you're in the photos. Richard, going in the photos. Bria, Elizabeth told me she's in
Take pictures. Yes.
You did amazing, guys. Good
Yes, we're coming.
حطيت زيادة حطيت بدون الغطا عشان الغطا
مضافة على
أحس كذا
كثير
أنا
كان
كثير
كلام
لا ومش أي أكل
عاد انتي
أسويه.
بالخليج عادي حرش.
خلاص
لا 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 والله لا والله والله زي لما يتهاوش على حسابه. Oh my god, it's my favorite time. Yeah, definitely. أحب أهاوش الناس.
إن شاء الله خير.
I'm wondering, do you think we should move this table out of the way? Right, like.
Worst case, 0 money. Worst case, 0 money, but we did good. This 0 money is not enough.
All right, get settled in, get settled in. All right, so all awards are by team. So the People's Choice Award is $1,000 for your team. I actually have no idea how we pay you if you're not at Texas A&M College Station, but my dear friend David does. So he probably pays in Bitcoin or something, I don't even know. So the People's Choice Award to me is pretty coveted because it's one thing for a group of adults to judge you and grade you on a rubric. Can we do that sound correct? But it's another thing to be voted first place by your peers. That's a level of respect to the people that your peers here in this room and your peers that wandered around. Because most of the people that came and vote were in fact students. And we had an amazing number of votes. Did we have 400 or 500 votes? We had like 4, yeah, we've never had anywhere close to that number before. That's And we did just a little bit of promotion. All right, so let's see. I think I know, but the last thing I want to do is mess up. So, yeah. All right, the People's Choice Poster winner and winner of $1,000 for your team is Carbon Cash. We want to take photos right here in front of this nice banner that we paid for. So you guys come spread out right here. So welcome. You're so welcome. I will just be behind here. I'll get a picture. I'll just put this behind you.
Perfect. All right. 3, 2, 1.
Good job. Now, third place and winner of $1,500 for the team, and maybe the world's biggest check. Is, well, I don't know why I had you sit down. Team Carbon Catch. You feel like organized behind the check, is that right, Dave?
Yes, and then we're going to have the check in the middle.
Check in the middle. Right here, you guys hold it.
Yep.
Make sure it's kind of square. Daniel tells us if it's not square.
3, 2, 1.
Good job. Go ahead. I don't know what you're doing. And in second place, and the winner of $2,500 for the team, Team Deep Blue. Got a lot of team members here.
Scoot in a little more.
Fill out the slots. A little more left, okay? Listen.
Scooch in. I need everybody to.
There you go.
All right. Great. Down a little bit more. There we go. 3, 2, 1. Thank you.
Nice. Okay, take it. All right. And the winner of first place for the 2025 Global Championship for Invent for the Planet, and the only thing that stands between you and getting to go to the Dixie Chicken and, you know, eat and, I don't know, whatever you want to do over there, is Team Aquarentures. Congratulations. Let's see, did y'all practice with me? I've never been a team that's won that didn't. Just telling you. All right, so y'all listen to Danny about where that needs to be to get centered. All right.
Okay, there we go.
Oh, yeah, come on. Okay, so y'all scoot that way a little bit. We'll put her right in here.
Okay.
Right. Right.
Everybody, 3, 2, 1. Thank you.
Okay, hey, would y'all not break formation yet?
I didn't get.
Lana's trying to get a photo here, and I think she feels like she recruited Jordan, so she's gonna be trying to take credit. Oh yeah, but let her get a picture first. It's just like, okay. Then y'all can do whatever you want to do.
3, 2, 1.
Thank you. The second place team, come back up. Fred, we had the third place up there. This is the second place. All right, the second place team. Yes, yes. Danny, People's Choice. Where? Out this door?
Yes.
All right, let's do it again. Lana, was it right for third place and first place?
Yes, it was.
Okay. All right. Smile nicely for Lynn.
Yes, so.
For Danny now. Okay. Before we leave to go to the Dixie Chicken, Brenda, I think they need to take all their stuff with them, right?
Dave, we have the room till 5 p.m.
Okay, so it'll be unlocked, or somebody will come with them.
Yep.
Okay, so you've got two choices. You can take your stuff with you if it's not too cumbersome for you to carry with you. If you want to leave it here, you can. But just remember, the room will lock at 5. The room will lock at 5. And the Dixie Chicken, somebody's going to lead us over there. But generically, you walk out to this street. You walk out to the street, and it's that way about a quarter of a mile, and it's on the right-hand side it's on the other side of the street from the university. One other thing, a big favor. If you won the People's Choice, or you finished in first, second, or third, please go right outside one of these two doors right here. Meet Danny out there. I think she's going to do a little interview for you that we'll use on social media. Please do everything you can to post this on social media. I hope to see all these universities back next year, and I hope to see a lot of universities in your region. Please help us promote the event. Thank you very much, you guys. It's been so much fun to get to meet with you in a few days.